So this video is a follow-up to the first lesson on the basic divisibility rules. In this one we are going to review the truly basic rules that we learned in the first video lesson, build up to the idea of some of the more advanced ones, present an opportunity to practice with those and fill in another chart, and then have a challenge at the end for you to think about for the next time we come to class. So first let's review quickly what the divisibility concept means, and in this case we're really talking about division, much like the divisibility, at least the divisa at the beginning there, that is very similar to division. The key point being that we are working without remainders. And that is the most important part of divisibility. It's division without remainders. And so we had a few rules to determine whether or not there would be a remainder when we go through certain division problems. And again, this doesn't give us what the actual quotient would be. It just gives us whether or not there would be a remainder. The divisibility rule for 2, the key point was that the number was even. For the divisibility rule for 3, we had to add all of the digits. And if that sum was divisible by 3, then the entire number was divisible by 3. The divisibility rule for 4, we just took the last two digits separately and turned them into their own new number and then checked to see whether that was divisible by 4. And then 5, very similar to 2, we're just looking at the last digit. Last digit has to be 5 or 0, and to be divisible by 10, the number has to end in 0. So I want to take a few of these basic divisibility rules and look at some Venn diagrams where we compare the results of one rule to another. So first, we want to separate these numbers 2, 3, 4, 6, 8, 9, 10, 12, 15, 30, and 25 into this Venn diagram, so that the numbers that are only divisible by 3 are here in the left circle, the numbers that are only divisible by 5 are here in the right circle, and the numbers that are divisible by both are here in the center. So go ahead, pause the video, draw the Venn diagram, sort the numbers like we into the Venn diagram, and unpause the video when you are ready to move on. So first we're going to notice there are some numbers that don't fit into any category, so we're going to keep them out. 2, 4, 6, 8, and those really are the only ones that don't fit into any of our categories there, so we're going to keep them out. 3 is divisible by 3 and 3 only. 9, as we saw, as we know, can be divisible by 3, but not by 5. 10 is divisible by 5. 12 is divisible by 3, actually. 15 is divisible by 3 and 5. 30 is divisible also by 3 and 5. And 25 is divisible by 5 only. Now, if we extended this a little bit with a few numbers, we'd find that other numbers such as 45, 60, 75, etc. would be part of the numbers that are both divisible by 3 and 5. And if you notice the pattern here, if we start with 15, we can multiply it by 2, by 3, by 4, and by 5, and we get the numbers that are part of this center category divisible by both 3 and 5. So with that kind of idea in mind, that's what the center looks like here, go ahead, draw a new Venn diagram, and do the same thing for those divisible by both 2 only, by 3 only, and then by both. Alright, so here we go. There are not going to be any numbers here that fit into neither category. 2 is divisible by 2, 3 is divisible only by 3, 4 only by 2, 6 goes in the center, 8, 9, 10, 12, 15, 18, and 24. Let's get rid of these red lines here. So this is what we have. 2, 4, 8, and 10 only divisible by 2, 3, 9, and 15 only divisible by 3, and 6, 12, 18, and 24 divisible by both. So I'm going to ask you to take a second, look at these numbers, and see what sorts of things do you notice about the numbers in the center. Well, there are a number of things to notice, and one of the things to notice is that it's all based around 6. All of the numbers in the center are multiples of 6. 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, etc. And that 6, conveniently, is the same as 2 times 3. And it turns out in this case, but not in every case, that this is enough to give us the divisibility rule for 6, because any multiple of 6 is going to be divisible by 6. That is almost by definition. We'll talk more about multiples when we get up to the unit on number theory, and we talk about factors and multiples. But here, the fact that 2 times 3 is 6, in this case is enough to make the divisibility rule for 6 the divisibility rule for 2 and 3. If it's divisible by both, then the number is divisible by 6. This does not work in every case, but it does work in this case. So go ahead, pause the video, write this part down, and then we'll move on. So let's take another number such as 75, and then we'll take a number like 102 and test to see if they are divisible by 6. Now 75 very clearly isn't, because it's not even, so it can't be divisible by 2, so therefore it can't be divisible by 6, but it is divisible by 3. For 102, it is even, so that works. It's divisible by 2, and 1 plus 0 plus 2 is 3, so therefore it is divisible by 3, and since it is divisible by 2 and 3, it is divisible by 6. Now the next rule we have to talk about is the rule for 8. The rule for 8 is very similar to the rule for 4. However, in this case, we are looking at the last 3 digits of a number rather than just the last digit or last 2 digits of a number. But otherwise, it is pretty much exactly the same rule. Let's go ahead and pause the video and write this down. If the last 3 digits of a number are divisible by 8, then the entire number itself is divisible by 8. So now if we take some examples, let's say we have 34,248. We only look at the last 3 digits, which are 248, and we treat them as a separate number, 248. Now this is as simple as we can make it here. We may have to divide to find out if 248 is in fact divisible by 8. If we do that, we end up with 31 with no remainder. So 248 is divisible by 8, therefore the entire thing is divisible by 8. So again, take the last 3 digits of the number, treat them as a separate number, and then use that result. If it's divisible by 8, then the entire thing is divisible by 8. If it's not divisible by 8, then the entire thing is not divisible by 8. The last divisibility rule that we're going to talk about is the one for 9. It is almost identical to the one for 3, except this time we want the sum of the digits to be divisible by 9. So if you haven't already, pause the video and go back and copy this down. We're not going to go through an example here because it's exactly the same as 3, but let's use that for these 2 examples here, the divisibility rules for 6, 8, and 9, to find out if 324 and 480 are divisible by those 2 numbers. So we're going to do these together, copy this down as we go along. For 324, let's look at 6. Well, 324 is even, so that means it is divisible by 2, and 3 plus 2 plus 4 is equal to 9. Since that's equal to 9, that means it's actually divisible by 9 also. But that means it's divisible by 3, and since it's divisible by 3 and 2, it's divisible by 6. Now for 8, 324 are the last 3 digits of the number, and if we divide 324 by 8, then what we end up with is 40 with a remainder of 4. Sorry, not a remainder of 5, with a remainder of 4. Or 40.5 if you took that out to a decimal point. So 624 is actually not divisible by 8, just by 6 and just by 9. Now for 480, we find the sum of the digits. We have 4 plus 8 plus 0, because 0 is a digit, is equal to 12. That is not divisible by 9. So 480 is not divisible by 9, but it is divisible by 3. And since 480 is even, it is divisible by 2. And so 3 and 2, since it is divisible by both, it is in fact divisible by 6. Now the last 3 digits of this are 480, so if we take 480 and divide it by 8, we end up with 60. And since, with no remainder, and since 480 is divisible by 8, well, 480 is divisible by 8. So now, go ahead, we've done this before, fill in these charts to find out whether or not 27, 120, and 36 are divisible by 3, 4, 6, 8, and 9. I added 3 and 4 there just so we can get some more practice with some of the other not quite so simple ones in the basic divisibility rules. Pause the video and come back when you are ready to go forward. So after filling out the chart, you should end up with the fact that 27 is divisible by 3 and 9, 120 is divisible by 3, 4, 6, and 8, and 36 is divisible by 3, 4, 6, and 9, but not 8. And so the last thing I have here is a little bit of an extra challenge. We talked before about how since 2 times 3 is 6, we can actually take the divisibility rule for 2 and the divisibility rule for 3 and turn it into the divisibility rule for 6. That is actually the exact same thing that happened when we had 3 and 5, and it turned out that the divisibility rule for 3 combined with the divisibility rule for 5 is the divisibility rule for 16, so that, or 15 rather. So the divisibility rule for 15 is if it's divisible by 3 and 5. And so the challenge is to come up with a few other examples of numbers that work for that. Give you a hint, it's not all of them. Not every number can be thought of as broken down into parts. And if you want an extra challenge, you can try to see if you notice what numbers fall into that category and what numbers don't. But try to come up with a few other numbers, if you can, that follow by the, if it's divisible by this and this, then it is divisible by that number.